One of the most important scientific instruments on board the James Webb Space Telescope has run into an issue. Webb's mid-infrared instrument, also known as MIRI, is currently experiencing problems, and NASA has decided to stop observations using one of its modes until they find a solution. MIRI has both a camera and a spectrograph that sees the light in the mid-infrared region of the electromagnetic spectrum, with wavelengths that are longer than our eyes see. While other Webb instruments cover a wavelength of up to 5 microns, MIRI has been developed to observe the universe in the wavelength range of 5 to 28 microns. Stretching the instrument capability to longer wavelengths is essential because when we look inside our own galaxy, we see dusty regions. Things are going on inside those clouds, inside the dust, that we can't see because dust is essentially opaque. But once we shift to longer infrared wavelengths, the amount of light that is absorbed by the dust drops. Hence, we can not only look at the surface, but also into the heart of the dusty region. So that means we can look at the center of our own galaxy and inside the dusty regions, where the stars are being formed more easily. In addition, we can observe faintly visible comets and objects in the Kuiper belt. MIRI has 4 modes: imaging, medium-resolution spectroscopy, low-resolution spectroscopy, and coronagraphy. On August 24th, during preparation for observations using MIRI's medium-resolution spectroscopy mode, the team detected a problem with a grading wheel. Its function is to select between short, medium, and longer wavelengths. During the setup process leading to scientific observation, the telescope detected increased friction in the mechanism, which caused the issue. This artist's rendering shows this path for MIRI's imaging mode, which provides imaging and coronagraphy capabilities. The pick-off mirror, acting like a periscope, receives the light from the telescope, shown in deep blue, and it directs it to MIRI's imaging module. Inside the instrument, a system of mirrors reformats the light beam and redirects it till it reaches a filter wheel, where the desired range of mid-infrared wavelengths is selected from a set of 18 different filters, each with a specific function. The beam takes a light blue color in the animation. Lastly, another set of mirrors takes the light beam coming out of the filter wheel and recreates the image of the sky on MIRI's detectors. The problem does not seem to have been caused by any external factor like a meteorite impact. Nevertheless, Webb has had multiple impacts since its launch and have caused minor issues to the mirror segments. But since the scientific instruments are well encased inside the integrated science instrument module, the problem seems to be due to some internal issue. Also, the problem does not threaten the entire telescope operations. Therefore, Webb has not been placed in safe mode. Instead, the Anomaly Review Board has paused medium-resolution spectroscopy aboard MIRI until they find a fix. So Webb continues to gather science data, only not in the mid-resolution spectroscopy mode of MIRI. The remaining modes of MIRI are still working properly, along with other science instruments. Despite the current issues, we should still expect new images to come. So recent releases of the Tarantula Nebula and the Orion Nebula definitely won't be last. There are many other modes that the observatory can use for now. Besides, there are many things that James Webb already observed but did not release to the public yet. They include images of the TRAPPIST-1 system, which it took during the first month of scientific operation. Just months into unfolding the universe, Webb has already challenged our current models of star formation and galaxy evolution. When scientists and engineers started building the James Webb Space Telescope more than 25 years ago, its primary objective was to enhance our knowledge of extragalactic astronomy. Since Webb is an infrared space telescope, it can peer further back in time than the Hubble Space Telescope, up to just 200 million years after the Big Bang. This means Webb has the potential to observe the era in which the first stars and galaxies formed. In addition, It can look at those regions of the cosmos that no other telescope could. We have discussed how Webb has challenged our current understanding of the universe in the 26th episode of the Sunday Discovery series. If you want to keep up with the latest discoveries by the James Webb Space Telescope, make sure to subscribe to our channel and press the bell icon so that you don't miss any Webb updates.